Suppose a company manufactures speedboats and operates with the weekly cost and revenue functions given, where X is the number of boats produced each week. The company is currently producing 340 boats per week, and our question is, should the company change production in order to increase its weekly profit? So this question is asking us to analyze profit, and yet we've been given a cost function and a revenue function. We don't currently have the profit function. So it would be helpful to begin by building a profit function. So we know that the profit that a company makes can be found by taking the total revenue, the amount of money that's coming in, and then subtracting off the costs to run that company. So your profit is equal to revenue minus cost. So since we know both the revenue and the cost functions, we can create a profit function. So the revenue function was negative x squared plus 2000x. This was a quadratic revenue function. And then we'll subtract off the cost function, which happened to be a cubic function. Now it's important when we subtract off this cost function that you have the entire cost function in parentheses, since it has more than one term. And we are subtracting, so we'll have to be sure to distribute so that we subtract every term. So I'm talking about this negative, we're treating this like a -1. It will need to get distributed throughout the cost function. So let's do that now and distribute that negative, and then we will combine like terms. So negative x squared plus 2000x minus 1 over 120x cubed plus 6x squared minus 2370x minus 4500. So combining like terms will give us a nice simplified profit function. I'm also going to take this opportunity to reorder the terms, and we'll start with the highest exponent, which would be the -1 divided by 120 x cubed term. And then we'll combine our negative x squared and positive 6x squared. So that's a positive 5x squared. We have 2000x and negative 2370x. So that's negative 370x minus 4500. So this is our profit function that now we can analyze to see if we should increase production. So before we move on to our graphing calculator, let's first analyze the shape of this graph. So if you think of the parent function of this graph, it's a cubic, an x cubed graph. And typically our x cubed graph is an S-shaped curve, something like this. However, we do have a negative leading coefficient here. So that tells us that our cubic is actually going to rise on the left and fall on the right. Now, it is probably going to have a minimum and a maximum. So when we go to the graphing calculator in just a second and graph this curve, let me erase my previous cubic, we're expecting a shape something like this. So it's always a good idea to think about what the shape of the graph should be prior to you plugging it into your calculator, so you have kind of an expectation. So our goal now is going to be to use our graphing calculators, and we would like to ultimately maximize profit. So we will be looking for this maximum right here. We call this a local maximum or a relative maximum, but this is the maximum that we're interested in on this cubic function. So in the next video, we will show how to use the graphing calculator to get an appropriate window and then find this maximum.